Today I'm going to be talking about modeling polynomial functions, and this is day 2 of chapter 5, section 9. Now, this one, we have some information that's given to us. It says the table shows the total U.S. biomass energy consumption, Y, and trillions of British thermal units, or BTUs, in the year T, where T equals 1, corresponds to 2001. Find a polynomial model for the data, and then use the model to estimate the total U.S. biomass energy consumption in 2013. So what we're going to do is we're going to take a look at this, okay? And we're going to actually put this into our calculator first to determine if this is a linear, a quadratic, cubic, or quartic function. Because finite differences in this case won't always work because it's real life information. It doesn't always fall in a completely, 100% linear, quadratic, cubic way. So we have to graph this into our calculator first to see what it looks like. So what we're going to do is we're going to go to our graphing calculator, okay, and we're going to make a scatter plot. Now when we make a scatter plot, we have to make sure second y equals that our plot is on. So we're going to go to 1 and push enter to on. So our scatter plot is going to graph correctly. Now we're going to put our information in. So we're going to go to stat 1, edit, and we're going to put in our information. So we have 1, and we go all the way down to 12. So it's 2, 3, 4. Okay, so 1 through 12. Now we're going to go over to line 2 and put in our corresponding information. So 2622, 2701, 2807, 3010, 3117, 3267, 3493, 3866, 3951, 4286, 4421, and 4316. So we're going to put in all of our information. Now, we have to be careful before we graph. We have to set our window correctly. So if we look at the window, our data goes through 1 through 12. So since our x values are 1 through 12, I kind of want to go a little bit below and a little bit above. So I'm going to do about 0 to 15. That should be a good range for x values. And I'm going to go by a scale of 1. But our y values start really high in the thousands. And so I'm going to go a little bit below, which is about 2,500. And I'm going to go a little bit above, which is 4,500. And then the scale, I'm going to do about 100 to get a really good scale and feel of this. So then I'm going to graph it. So make sure your window is correct. Now if I look at this, it kind of could be linear, not really quadratic, but it kind of has a curve to it. So if I were to draw a line around, that kind of looks like a cubic. It kind of looks like a cubic. So what we're going to do is we're guessing that it's a cubic function. So we're going to use cubic regression to find this equation of this line, this best fitting line. So we're going to go to stat, calc, and we're going to do cubic regression 6. Since we already have our information in, we can just go straight to cubic. And now I'm going to calculate, okay? And now we're going to round to the nearest hundredth for this one. So our function is going to be a negative 2.55 x cubed plus 51.95 x squared plus, oops, that's a negative, 118.11 x plus 2,732.14. Okay, so we're going to use this, and we're going to go to our y equals and plug it into our y equals. So it's a negative 2.55x cubed plus 1.95 x squared minus 118.11x plus 2,732.14. And now we're going to graph this. And we can see that this follows very closely to our information. So we're pretty solid that this is a cubic function. Once we know that this is a cubic function, okay, the equation we wrote was our model, the next step was to estimate, let's go back to it, to estimate the biomass energy in 2013. Well, that means our x value would be 13. So we can go back to our calculator and do second trace, and we can go 1, which is value, and we can plug in 13 for x, and we can estimate about 4,373, and I believe it's trillion BTUs.